Okay, so the next thing we're going to talk about is actually applying that formula to take a derivative of a function. So we have the function y equals 2 raised to the t minus 3, and the textbook wants us to find what value of t of this function will give us the slope of the tangent line that equals 21. So this is an exponential function because we have a base of 2 raised to the power of t. And I'm going to graph this, but actually, well, let's not graph it, but basically what we're trying to do is we're trying to find when the tangent line of the graph is going to have a slope of 21. And so just like any other problem, what we need to do, I think the first step would be for us to actually calculate the derivative and then set it equal to 21. And so that's what we need to do. So we're going to take y prime of this function, and then it should have the variable t in it somewhere. And then we're going to set that expression equal to 21 and solve for t. So y prime then would just be the derivative of 2t minus the derivative of 3. So remember that the derivative of an exponential function in this case should calculate to be 2t the natural log of 2. And then we tack on the derivative of t, which is just 1. And so we get that y prime is equal to 2t times the natural log of 2 times 1, and then the derivative of negative 3 is just 0. So then that is y prime. So the next step is to take this expression, clean it up a little bit, and then set it equal to 21. Okay? And then we solve for t. So we say 21 is equal to 2t times the quantity, the natural log of 2. Now don't forget that the natural log of 2 is actually equal to 2. I probably should note that to solve for t, what I want to do is get t by itself and all the other stuff on the other side of the equal sign. So the first step in that process is to divide both sides by the natural log of 2. And so what I end up with is 21 over the natural log of 2 is equal to 2t. Now to get the t away from the 2, the property of logs allows me to toss that power to the front. So I'm going to take the natural log of 21 over the natural log of 2 and set that equal to 2. Now, if I want to, I could take that t on the right-hand side and toss it to the front. So what I have now then is the natural log of 21 over the natural log of 2 is equal to t times the natural log of 2. And I'm going to pause right there. Okay, so if I divide both sides by the natural log of 2, now on the left-hand side I've got a bunch of numbers, whether you realize it or recognize it or not. Those are all just numbers. And so what we want to do then is plug that in our calculator. And so if I take the natural log of 21 over the natural log of 2 and then divide that by the natural log of 2, I'll get a number, and that will be set equal to t. And so if I plug all that in the calculator, I actually end up with like 4.92. You could, I suppose, if you wanted to, kind of use some of the properties of logs to split that up. And so if I split this up, I could say the natural log of 21 minus the natural log of 2 all over the natural log of 2. Now I forgot to write down the natural log of 2. Don't worry about that. Just plug it in your calculator and you should get 4.92. I'll try to make a little side note at the end. I forgot to write it down when I originally recorded this. So what that means is that when t equals 4.92, then the slope of the tangent is 20.